Hello again. This is Mrs. Becky, and today I'm going to be going over IXL section X S1 in pre-calculus, and that's the properties of sine functions. Um, so we're going to learn how to identify um, all the different properties of the sine function, including the amplitude, period, phase shift, which is also a horizontal shift, and the vertical shift. So both from the graphs and also the equations. I'm going to be going over several examples, but they might not all be needed because the notes that I've given to you have explanations on them. So you can feel free to scroll through this video as is needed. Okay, so jumping right in here, just a few basic things about the sine function is right here it says the basic parent function, which is just like the very basic sine graph before anything is done to it. It goes through, or it has points at the origin, which is 0, 0. So we know it goes through there. Um, well, it actually, well, I didn't do those points right. Hang on, let me fix that. Okay, so it starts, it has a point at the origin right here, 0, 0, and pay attention to how the x-axis is divided in terms of pi. So here is 1 pi, and so it's divided up, each pi is divided into fourths. So two of those fourths would be half a pi. And at half a pi, you're going to have a coordinate right here at where, where y is 1. And then it's going to loop back down over here to pi where y is 0. And then it goes down to -1, where pi is 1.5 or 3/2. And it continues on that pattern and also goes that way on the negative side of the x-axis. So it goes over to negative half of a pi over to negative pi. But you do have to pay attention to how that scale is divided and then just deal with them as fractions. Okay, so um, a period is it's easier to see. It's where one complete cycle is made, and it's easier for me to see them at these high points, which are the maxima. So from maxima to maxima, or from minima right here to minima, that's one period. So this one goes from a half of a pi over to 2.5 of pi. So that's how you would calculate what the period is of these graphs. Right, the next thing is that amplitude can be seen from the height, how tall that this graph goes to how low that it goes. So it goes up here to 1. So from 1 to 0 is 1 unit, and then from 0 to -1 is another unit. But we only take the amplitude is half of the whole height of it, or you could just look at this part right here. Here's your amplitude. All right. Next, we have, which I've already been talking about him, is the maximum. So the maximum height of the graph only goes to when y is equal to 1, and its minimum is when y is equal to -1. And lastly, I believe, is the midline in here in red. The midline of this very basic parent graph is right along the x-axis, but it's going to be um, um, which, whatever the line that divides it in half, the max to the min. So the midline is the middle, divides that right in half. Right on this first example of this graph, it is asking you to find the period. To do that, you're going to look for the distance between two maxima or two minimums. You can see again that you want to notice how many the units are divided up into. So this is divided up into fourths of a pi, and our minimum here is 3/4 of a pi, and over here it's at 1 3/4 pi, or you can call it 7/4. I mean 7/4, 7 pi over 4, whatever. And then when you subtract that, you find that the period is just pi. Here's another quick example where they're asking you to find the period. And again, you want to notice how many units that the pi is broken up into, and just pinpoint any two maxima or any two minima and decide what their value is, and then just subtract them. So this one is at 5/4 pi, and to find the difference, take away 1/4 pi, and that leaves us right here with pi again. Next up, this question is asking us to find the vertical shift from the graph. So what we want to do is find out how far it, the midline is from the x-axis. So first you have to find the midline. And the midline, again, is going to be between, the height of the graph to the how low it goes, the maxima to the minimum, maximum to minimum, and then it's going to be the middle of that. So this midline is at y equals 4. So that's 4 units to get down here to the x-axis. And so the vertical shift on that one is just simply 4. Right? For this one, we also want to find the vertical shift. So what we need to do is find the midline. So this graph goes, its height is up to 5 on the y-axis. It goes all the way down to -3. Now, anytime you're dealing with distance, it's the absolute value because distance is always positive. So you would just subtract 5 minus -3 um, is going to be 8 units. And then we're going to divide that by 2. And that's going to tell you how far, what is the middle of the graph. So that is at 4. So if we're starting up here at 5 and we go down 1, 2, 3, 4, this is our midline right here. Then now the vertical shift is how far is the midline from the x-axis right here. So it's just 1 unit away from the x-axis. So the vertical shift on this guy is 1. Next, you're going to be asked to find the amplitude from the graph. And what you will do is find the vertical distance on the y-axis from its tallest point down to its lowest point, maximum, minimum, and then you're going to take half of that. So again, pay attention to your scale over here. Each line is a half of a unit on the y-axis there. So from this maximum here, this is at y is 1/2. So from here down to 0, that's 1/2, and down to its minimum is another half. Um, and so you're just going to take half of that, which is going to be 1/2. So your amplitude is going to be 1/2. But if you're going to do it math way, it's going to be absolute value. The reason, again, absolute value is because you're talking about distance. So it's going to be 1/2 up here, take away -1/2. You're going to divide that by 2, and that ends up being 1/2. So the amplitude of this one is 1/2. All right, next one is also amplitude from the graph. And so its high point is at -2, and its low point is at -6. So do the math way. It's going to be -6, and that's the absolute value. -6 minus -2, and that distance is -4. Divide that by 2, which is 2. So the amplitude is is a 2 units. So halfway is right there. There's our amplitude, splits it right in half. Next, we have finding these properties from given equation. So here is the equation of what it looks like right here. Mm, mm, That's what the equation looks like. So you will have, they always say f of x, y, and then so the number that you have with sine, that's your a position right here. the number that is hanging out with the x coefficient, that's your B position. C is added or subtracted um, to x variable. And then outside the parentheses over here, you've got the D number. So you just need to be able to identify those. And so when we're looking for the period is the B variable right there. And you're going to plug it into this little formula. So the formula for that is 2 pi over absolute value of whatever B is. Right? So it's going to be 2 pi. Then we just have to figure out what is B. Well, it's the one that hangs out with the X value. So that is the absolute value 4. And then just reduce it. So this reduces to 1/2 or just simply pi over 2. So this is going to be your period. Now on your notes, I have this kind of written out for you so that you don't actually have to watch this whole video if you don't want to, or you can just scroll through to the ones that you're not quite understanding. Okay, then on this one, down here, this is also looking for a period. So you just have to identify what each each A, B, C, D is. So we need the B variable. All right, and so our formula is going to be 2 pi over the absolute value of whatever B is. Well, this right here is B, 2/3. So that's 2/3. Um, then choose another color. You remember we're not dividing. We're going we're going to multiply the reciprocal, which is going to be 3 over 2. That then we these twos cancel out right there. So what that leaves us is 3 pi over nothing in the denominator. So that is your period right there. Next, we're talking about the horizontal shift or the phase shift. And here's what it looks like in the graph. So if you had your graph right here, remember I told you that the original graph goes right here through +1 and 1/2 pi. So that's where the original graph goes. So to find the horizontal or the phase shift from a graph, you're going to have to calculate how far this is according to your scale right here, and just subtract. And then you have to figure out, did it shift right or left? Um, that's how you do that from the graph. But because the C is inside these parentheses, and some of the formulas have this as a minus C. That's when it gets tricky. So if the graph is moving to the left, that's actually going to be positive in our formula here. But if it's moving to the right, it's actually going to be negative. So there's a formula here, right here. Our formula is going to be negative C over the absolute value of B. So we need to find out what C is. C is our phase shift right there. So it's the one that's added or subtracted to the X guy. So in this problem, there's no number here, which we can assume is 1. And right here, C is just pi. So we'll plug that into our formula. So it's negative C. mm, Um, C, negative. Okay, because yeah, C is negative pi. So plug that in. But formula is the negative. So you got to have this negative is this one right there. This negative is this one right there. That's why I use parentheses, because it can get confusing. All right, over the absolute value of B. And B is 1. Oh, that's 1. Because there's no number there, we assume that it's 1. That's pretty messy. Anyway, so these two make it positive pi. And since it's over 1, but it's just positive pi. So that's the phase shift on that one. All right, for number 10, they want a phase or horizontal shift. Also, so the formula again is it's minus C over the absolute value of B, right? So this minus sign right there comes from the formula, right? So we start plugging that in. So C, we notice, has its own minus sign. So the way to be careful with that is C is negative 2 pi. Those parentheses um, around what you're plugging in just saves you a lot of headache later. It's the absolute value of B. B is a 2, right? These two negative signs make that positive 2 pi over 2, and that just equals pi. So the phase shift on that one is pi, which I forgot to say on the notes there. I think there was a negative there. So that is incorrect. So I have to fix that. So on your notes, make sure that doesn't say negative pi right there. These next two are actually pretty easy. We are talking about the vertical shift from looking at the equation. So the vertical shift is going to be the value that is your D value right there. So that's what we're looking for. Now, if you're looking at this right here, this um, equation, there is nothing right here. So you can add a 0 safely and it doesn't change anything. So the vertical shift on that equation is actually 0. Then if we're looking at this next problem down here, the vertical shift on that one, D is negative 3. So the vertical shift is going to be negative 3. That was not too bad. All right, on this last example, I went ahead and put on there, which your notes don't have, vertical shift from the equation is going to be 4 because that's what D is, but it's a little bit more difficult to find the phase shift. Again, we're going to use this, this formula for the phase shift. So it's going to be the opposite what C is. And this is C right here, which is 5 pi over 6. And um, so 5 pi over 6 over B. And this is B. There's nothing there, so we can assume it's a 1. Right? So that is that negative is gonna make it negative 5 pi over 6. And if that's over 1, it's just simply negative 5 pi over 6. There you go. So that's all I have for the examples on this one. And so hopefully that's helpful for you guys. And till next time, see ya.